Okay, we're now recording. So you gotta chill out. We're gonna finish our puzzle in just a few minutes. We're only gonna do a little bit of notes today. You're gonna finish the rest of the notes tomorrow without me because I'm not gonna be here tomorrow. But unlike last Friday, you're going to actually be productive because Ellie is going to put the recording on, and so everything is going to get done because you do not want to be in trouble with me again. Okay, so let's go over these bell ringers and then we'll talk about our notes for the day, and then I'll let you get back to your puzzle. Let me start by saying I just gave a bonus to those who had finished the 6-4 worksheet. One thing that's going to happen during the video tomorrow is I'm going to put my key to the 6-4 worksheet on the screen so you can check your answers. If you've not done the problems, that's not going to help you at all. So make sure you get your 6-4 worksheet done today. I'm going to get asked for it to be turned in tomorrow. So, yes, I just saw Ellie's, but she's going to turn it in and prove she's done the front side of the notes too tomorrow. I'm going to leave these exact instructions that are coming out of my mouth also on the board. So there's no way that anyone can miss. Miss Compton not only wants our 6-5 notes, but she also wants our 6-4 notes. I'm going to take up like 3 different things tomorrow. I'm going to talk to Ellie about handling that for me in a second. Okay. The first question says, given the triangle shown below with exterior angles, the measures x, y, and z as shown, what is the sum of x, y, and z? X, y, and z. Did you actually calculate it, or did you just know the answer?
I actually calculated.
Can you tell me the value so I don't have to?
There are 108,
123?
123.
108 was this one. And then
129 was the one on the right.
129 is the one on the right, which means this inside value is what?
And that would be 51.
And then what was the outside value over here?
123.
123. Okay, so Derek has actually done all the calculations that we wanted. He first saw that it was a triangle. He solved for the third missing angle. He also knew that he had a lot of linear pairs, so he could do 180 minus the value to get the outside value. 180 minus the inside value to get the outside value. 180 minus the inside value to get the outside value. That's great. He's doing a whole lot of work, though, just because he likes math. Okay, what did you end up getting? Okay, so you said 123 plus 108 plus 129, and you got 360? Why did that happen? Because all exterior angles added to 360. So Ms. Compton appreciates Derek for actually doing the math and calculating everything for us. I didn't calculate squat when I saw this problem. I saw 3 exterior angles. I learned from the mistake you just made on that test that the sum of the exterior angles is always 360. So I put 360. Thank you, Derek. Okay, question number 2 says, which of the following is the slip of a line parallel to this line in standard coordinate plane? Parallel. Is the answer even up there? Yeah, what is the answer? Is the answer on the screen? It looks like it got cut off or something. We need to make an E. What is the answer?
I don't know. I didn't see the answer.
Parallel lines have what with their slope?
Same slope.
They have the same slope. So what should the answer be then? 2 over 3. She just walked in the doors, ladies and gentlemen. She had her Wheaties this morning. Okay, are there any questions about these bell ringers? Well, Junior's halfway tuned me out, so I'm going to make sure he understands now. The 6-4 worksheet that he didn't do and a lot of us didn't do, even though I wanted it done, it needs to be in the bucket tomorrow done. Because at one point, when I talk to myself tomorrow in my video, I'm going to say, here are the answers. Make sure you have them. Okay, so moving on, I'm going to let you spend most of the class period on your puzzle. We've just got to do a little bit of notes today. Take out your yellow sheet for me. You're going to need it. And you're also going to need the notes that I just passed out to you. Okay, while you're getting out your stuff, so far, we've been talking about quadrilaterals. We just took a test on parallelograms. No, I still haven't graded it. My bad. Struggle of a week for me. The second kind of quadrilateral we talked about was a rectangle. A rectangle was different from a parallelogram by two things. What are the two important things? 4 right angles. And the diagonals are congruent. Perfect. So in a parallelogram, this tiny piece is equal to this tiny piece, but we don't know that this whole length of the diagonal is equal to the whole length of this diagonal. We do know that with a rectangle. The diagonals match. There are right angles in each corner. There's also a lot of problems that ask you to solve the triangle. What kind of triangle is this? It's an isosceles triangle. So just FYI. Otherwise, rectangles would be too easy. So they do a lot of problems involving either solving the triangle, or they do a lot of problems with like this angle and this angle, because we talked about those being alternate interior, that kind of thing. Otherwise, they'd be too easy. They got to step it up a notch somehow. Okay, your puzzle was as hard as it gets, I think, for regular geometry. So if you were able to do all the puzzle pieces on your own, then you would definitely make an A on the next test. Okay, so 6-4 is one section. 6-5 is the section we're covering today. We'll cover 6-6 hopefully on Friday. We could technically take a test on Tuesday. We could review Monday, test Tuesday. I'm leaning to moving it to Wednesday. I probably won't cry if it's Wednesday, but if I move it to Wednesday, it better be a really good grade. Okay. So today we're going to talk about a new shape called a rhombus. And tomorrow Ellie's going to play a video of me talking about your favorite, the square. Okay, so if you look at your handout, it tells you characteristics of a rhombus. One thing is that opposite sides are parallel, so we can mark the parallel if we want to. Another is that opposite angles are congruent. I'm just going down this checklist. Opposite angles are congruent, so this angle matches this angle matches this angle. So far, it's sounding a lot like a parallelogram. Also, it says diagonals bisect each other. Again, like a parallelogram, it means they were cut in half. In fact, I'm going to make it look really similar to my other drawing. I'm going to put one dash here and like an X marks the spot there. So the tiny pieces are equal because the diagonals bisect. Again, so far, everything we've done on this figure for a rhombus is just like a parallelogram. So we've got to figure out what makes the rhombus special. The next thing it says, consecutive angles are supplementary. So we have that. The one rainbow plus the two rainbow adds up to 180, 180, 180, 180. We already have that. Again, everything just like a rhombus. The only characteristics that are unique to again, just like a parallelogram, the only characteristics that are unique to a rhombus that a parallelogram doesn't have are the 3 on the list with asterisks next to them. Those are the important ones. So if there was something I needed to learn about a rhombus, it would definitely be those 3. I might even put a little star next to them. The first one says that all 4 sides are congruent. So if I put 2 dashes here, I can do 2 dashes below, but I can also do 2 dashes on each side. All 4 sides are congruent. What other kind of shape has all 4 sides congruent? It's your very favorite. A square, which is what we're going to talk about tomorrow. A square. Okay, so all 4 sides are congruent. The next unique thing about a rhombus is that the diagonals are perpendicular. So what does that mean I need to add to my picture? If they're perpendicular, what do I add? How do I show that on my picture? Yes, with a right angle. Now, if I wanted to, I could draw a right angle everywhere, but as we discussed, that's kind of silly. Once you draw the one, it's implied that the others follow. The diagonals are perpendicular. Okay, and last but not least, so again, it seems like we're always talking about sides, diagonals, and angles. We talked about the sides, all the sides are congruent. We talked about the diagonals are perpendicular in this. And so there has to be one more unique thing about the angles, and that is that the diagonals actually are cutting this angle in half. So if I were to do, I'm going to change that to a 3 rainbow. This one rainbow goes with this one rainbow. These two. And it's still where the opposite ones are congruent because they're alternate interior. So 2 rainbows, 1 rainbow. To make that a 4 rainbow, I need to make this one a 4 rainbow. I've gone a little rainbow crazy, but you get the gist. The angles are cut in half by the diagonals. Okay, are there any questions about this? We're going to work a few examples, and then we're going to go back to our puzzle. So if you want to put your yellow sheet away, you can. We're going to fill in the last little block in the yellow sheet tomorrow. Again, the whole point of this yellow sheet is that I'm going to give Junior this yellow sheet blank for the test next week. If Junior understands what these markings mean, he can go ahead and make all these markings and use this sheet throughout the whole test. Heck, I'm going to throw in a bonus for it if his is a good one. This should help Junior on the test if he's been filling it in and he knows what it means. If it just looks like something's a caveman drew on the wall, then that does nothing for Junior. Okay. We have 5 examples we're going to work. Some are fast, some are slow. And you know I'm going to ask you if it has to deal with a diagonal, an angle, or a side, because lately I've been slowing up on that answer. Okay, so question 1, are we going to use angles, sides, or diagonals? How do you know it's angles? Because it says angle ABD. Okay, it says ABD, which is here. Again, the middle letter is important. ABD would be there. They tell you it's 60. And then they ask you to find BDC. What is BDC? Well, I'm going to make an A on my next test, so I know the answer already. What is the answer? Why is it 60? Because they're alternate interior angles, so they're supposed to match anyway. It is 60. Very good. Are there any questions about that? That's as easy as it gets with rhombuses. On the next one, we see AE is 8, and they ask for the length of AC. They ask for the length of AC. I would love to hear from Jarrell's table. What is the length of AC? It is 16 because 8 plus 8 is 16. Are we using diagonals, sides, or angles on that one? It was diagonals. Good. Okay, are there any questions on number 2? You have a question? Yeah. Okay, let's go on to number 3. Now, Ms. Compton did a boo-boo, which is that every single question is using that exact same figure. And since I'm not writing in pencil, I can't erase it. So they're telling me CEB is, they want me to find that. Well, maybe they say I can keep it. I don't know. Okay, never mind. I'll take all that back. Find CEB. CEB. What is CEB? Why am I supposed to automatically know that? This is what would be special about a rhombus. It is a right angle. So what number do I put? Okay, so I know angle CEB is 90 degrees. And again, that's unique to a rhombus because the diagonals, it always looks wrong, are perpendicular. That does not happen with a parallelogram or with a rectangle. Okay, and then my picture's getting a little crowded, so I'm going to draw myself a new one. Maybe. Maybe not. A, B, C, D. And where they intersect is E. Okay, they asked me to find CBD, which is here. Well, no, they tell me CBD is 58. And they asked me to find ACB, which is here. Now, if this was a rectangle, I would know the answer is 58. Because, again, there were a lot of isosceles triangles going on. But this is not a rectangle. This is a rhombus. So what am I going to do? You can. So Ayana's noticed that this is a triangle. So I'm going to draw a picture of the triangle Ayana's referencing. She knows that this one was 58. She knows that there's a right angle here because that's where the diagonals meet. She needs to find that last angle. So she said to do 90 plus 58. What did you get? 180 minus 142, 48 is 132. Thank you. Or just 32. Thank you. So, angle ACB is 32 degrees. Again, after parallelograms, rectangles, rhombuses, and squares, they seemed a little too easy for a normal geometry kid. They are. You've already talked about rectangles and squares like in middle school and elementary school. So to step it up a notch, they do a lot of questions where they ask you about a triangle within the figure. Now, you still have to know stuff about the shape. For instance, you had to know to put the right angle there. But otherwise, it's really a triangle problem, which we should already know how to do. Okay, and last but not least, it says AD is 2x plus 4. CD is 4x minus 4. And they asked for me to find x. Well, this seems hard, because normally, if they're on top of each other, like if I had put the 4x minus 4 up here, I would have just said, oh, they're equal. What am I supposed to do this time? Because we had opposite sides congruent with rectangles and parallelograms. What's special about a rhombus? You're smart. You can read up above. There were 3 things we were looking for on a rhombus that made them special. What's got to do with the sides? That they're congruent. Parallelogram and rectangles have parallel sides too. If you look back at the characteristics, I said there are 3 you might want to memorize. One of them is all 4 sides are congruent. So I still set these 2 equal to each other because they are congruent. So 2x plus 4 equals 4x minus 4. Solve for x. I get x equals 4. And that is my answer. And if I was really trying to make an A on my next test, I, of course, would check myself. 2 times 4 plus 4. 8 plus 4 is 12. 4 times 4 minus 4. 16 minus 4 is also 12. So I know I'm right. Are there any questions about this? So again, rhombuses, whole new shape, have a lot of stuff in common with parallelograms. The 3 things that make them unique. All 4 sides congruent. diagonals are perpendicular, and the diagonals bisect the angles. Okay, I've rambled on long enough. You can put that